Well, I'd like to go over a couple of the examples we did do on Thursday last week in 2.1, and it was just practicing taking some derivatives. So the first example we looked at was f of x was negative 9 pi e to the pi, and they just want us to find the derivative. Now they're trying to be tricky here, but this is just a constant, and we saw in 2. I'm sorry, this is a 2.2 problem. From 2.1, we showed that a derivative of a constant is a constant. Derivative of constant is 0. Limit of constant is constant, but a derivative of a constant is 0. So this is a constant, and the derivative of it is 0. The second problem we looked at was the fourth root of x, and it was more helpful to write the fourth root as a rational exponent, 1/4. Remember that your power rule, just what we did with the exponent is the exponent comes down and then we subtract 1 from the exponent. So when we take the derivative here, the 1/4 comes down and then we subtract 1 from the exponent. So this will be 1 over 4, fourth root of x cubed. And that's using a combination of a couple of exponent rules that I will mention here. So definition of a to the m over n is the same thing as the nth root of a to the m. If I have a to a negative exponent, it tells us that it goes in the denominator, so 1 over a to the m. And then if we combine these two, we get this last one. If I have a to the negative m over n, it'll be 1 over the nth root of a to the m power. So that's what happened here. This fourth went in the denominator, and then we have fourth root, and then the third power is on the a or the x in this case. Okay, let's get all that stuff out of the way. And C, g of t is equal to pi cosine t minus t squared plus 5t plus 3x to the fourth. Again, they want us to take the derivative. One of the properties said that if we have a constant multiplied by a function and that function is differentiable, then the constant's not going to do anything. It's just going to hang out, and if it's pi, then it's going to be pi times the derivative of the function that we took the derivative of. So that pi is just going to hang out. So here's the pi hanging out. The derivative of cosine is sine, negative sine of t. And then we'll apply the power rule on the t squared, so the 2 comes down. So it'll be 2t, and then subtract 1 from the exponent, plus 5. And then I'm going to write it out. The exponent on the t here is a 1. Let's see if I can get that. Put a 1 there. Okay. So that exponent 1 comes down. It'll be t to the 0, but t to the 0 is going to be just 1. And in 3x to the fourth is treated as a constant. Because we're taking the derivative with respect to t, the x is just treated as a constant in this case. So it doesn't add anything. Okay, so cleaning that up, this will be negative pi sine t minus 2t plus 5. Okay. Another example we looked at is y equals 5 over 2x quantity cubed plus cosine. And what we did first is, just to make it a little bit more friendly, is I went ahead and cubed the 2, so 2 cubed is 8. And then we had x cubed in the denominator. We can use our exponent rule and rewrite x cubed in the denominator as just x to the minus 3 plus the 2 cosine x. So when we take the derivative here, it's going to be 5/8. 5/8, that's constant. It's just going to hang out in front. We're going to take that negative 3 coming down using the power rule. And then we're going to subtract 1 from the exponent. So negative 3 minus 1 is negative 4. And then the derivative of cosine is sine. So we got that 2 hanging out in front. So it'll be plus 2 times negative sine x. Cleaning that up a bit, 5 times negative 3 is negative 15, 8 in the denominator, and then the x to the minus 4 we can write as x to the fourth in the denominator minus 2 sine x. Okay. E f of x was 2x to the fourth minus x all over x cubed. We don't have the quotient rule yet, but we can trick this into looking like something that we can do, and that's split this up into 2. It's going to end up being 2x to the fourth over x cubed minus x over x cubed. Just splitting that fraction up into 2 pieces. The first one, you got 4x's upstairs, 3x's downstairs, so you'll have 1x left over in the numerator, so it's just 2x. And then what you got to be real careful about here is the second one, have 1x upstairs and 3x's downstairs. So I'm going to have 2x's left over after we divide out the like factors. However, the x's are going to be in the denominator. And so it would be 1 over x squared, but I'm skipping a step here. Instead of writing 1 over x squared, 1 over x squared is the same thing as x to the minus 2. And if you recall, when I'm dividing like bases, I subtract the exponents. That's another way we can think of it here. The 4 minus 3 was just the 1 here. And then, let's see, 1 minus 3 is negative 2. So there was another way of thinking about that. Okay, so we're going to use the power rule on both of those. So f prime of x is going to be equal to 2 times 1, x to the 0. So the 1 came down, we subtracted 1 from the exponent, minus the negative 2 will come down, and we'll subtract 1 from the exponent to become a minus 3. Cleaning it up, the x to the 0 is 1, so it's just 2, and then we got 2 negatives plus 2, and then we went ahead and put that x to the minus 3, put it back in the denominator. Alright, I think we got 1 or 2 more. Letter F was f equals 2 divided by cube root of x plus 3 cosine x. So for whatever reason, I really liked cosine when I was making these examples up, but it's fine. You can put a sign in there if you want. Derivative of sine is cosine. I'm going to go ahead and rewrite this as something a little bit more friendly to use the power rule. So it's going to be 2, and then it's cube root of x, so it's x to the 1/3. However, it's in the denominator, so that's where this minus is going to come from. So it's x to the minus 1/3. So the 1/3 takes care of the cube root. The negative says it's in the denominator. Plus 3 cosine x. So we're going to take the derivative. The 2 is just hanging out in front. Come on, let's play. And then we'll subtract 1 from the exponent. So the negative 1/3 comes down. Subtract 1 from the exponent, so we get negative 4/3. Plus 3 times derivative cosine is negative sine. And then we'll clean it up a bit. So we have negative 2 divided by 3, and then the denominator in the exponent there is going to tell us the root. So it's cube root x to the fourth. And because the exponent was negative, that tells us it's going to be in the denominator, minus 3 sine x. Alright.